I want to go back to your discussion of the Hadoop stack.
Okay.
So, I don't know, these days the word Hadoop comes up and almost as quickly the word Spark comes up. So Spark, of course, is another Apache open source project with big data applications. So first question, would you consider Spark part of the Hadoop stack? Or do you see it, is this an either or is this a both?
Yeah, so the first answer to that question, and I've had the opportunity to watch Spark mature from the early days. And in fact, Mike Franklin, who is the head of the AMP lab at Berkeley, where Spark was created, and now the department chair, is on our board of advisors, as a matter of fact.
Okay.
And Mike's been a great counselor to the company. But I've watched Spark since the beginning, and let's see. To be technically accurate, Spark exists independent of Hadoop, to be technically accurate. Having said that, though...
Market realities, though.
Market realities and technical realities yield it works best in concert with Hadoop. And the way I like to think about it is that Hadoop really provided us two fundamental things in its early days. It was an analog of the Google file system, so the Hadoop file system, and an analog of Bigtable, which was HBase, and an analog of MapReduce. And MapReduce was the first time as a computer scientist for me, and I remember when I was first exposed to MapReduce, it was at an advisory board meeting for the Dean of Computer Science at Carnegie Mellon University. I sit on his advisory board. And he presented the Google paper on MapReduce and said this is going to change everything and all of our research is going to revolve around this big data architecture. And the beauty of Hadoop at that time was that it made distributed computing accessible by the average computer scientist. Beforehand, you had to have some specialty, a master's or a PhD in distributed systems, to do anything with tens, hundreds, or thousands of computers simultaneously. Because there's so many issues to deal with, locking up the system, synchronization, clock synchronization, deadlock, and all of the other issues, failover. And now MapReduce was an abstraction that let programmers get at that.
So the stuff that we were calling grid computing or high performance computing or
Back
cluster computing,
you gotta be an
relatively
expert.
high barrier to entry,
Relatively
kind of a priesthood.
Right.
And Hadoop lowered that barrier.
It democratized distributed computing, right? All of a sudden, everybody can run on thousands of machines.
Yeah.
And not only that, with the simultaneous emergence of the cloud with Amazon, you didn't have to go procure or provision those machines, right?
Yep.
You can go light up a job, run it, and then shut it down.
Right.
So it was a fantastic convergence. And this is great. But
timing was good.
timing was great. But MapReduce is a fairly abstract concept. Taking any complex, sort of algorithm or task and breaking it into a mapping function and a reduction function is something that is really pretty abstract. You have to be pretty mathematical to think about that. And so there were limitations on what kind of skill sets the people had that used Hadoop.
Yeah.
Now-
Ostensibly, any Java programmer could approach this thing, but in reality, it's not so much about the programming language, but the kind of the algorithmic
The thinking.
Mindset.
The mindset. And now Spark comes along with a different perspective. It is invented in the context of distributed computing, but it takes a set theoretic view of manipulating data. What do I mean by that? I mean that it thinks of things in terms of sets of data and applying functions or transformations and operators to that data to result in other sets and then in other sets. And this is a very natural way for programmers to think, and especially database people.
I was going to say SQL results sets and sets sound like they have some affinity.
There's a great deal of affinity here. Now, Spark started before its SQL layer, and it was still a programmatic API.
Right.
But still, that programmatic API was far less esoteric than map and reduce functions. It was, okay, let's apply a projection and let's filter that out according to some predicate. So I have a smaller set and maybe I want to join two sets together. It was very intuitive, right? So it took off. And not only that, it was highly performant for a variety of reasons. Spark is an in-memory architecture. It doesn't require you to write to disk for its interim results, whereas MapReduce did. And it also...
That said, it can spill to disk if it needs to, which
yes.
gives it a leg
Scalability.
up on a lot of pure in-memory systems.
That's exactly right.
Which break once you've hit the memory limit.
So you don't need to be all in
Right.
memory, but it can take advantage of the memory. And it had a nice pipelining architecture too, meaning as you go through this sequence of transformations, the second and third and fourth transformation don't have to wait until the first one finishes because it pipelines its operations as the results start flowing through. Whereas MapReduce, as you do mapping, you wait for that to be done. All of the results come over to the reducers, and the reducers run. So
And
fundamentally,
you can daisy chain those things together, but they're synchronous. One has to finish before the next one kicks off.
Exactly.
Whereas the way you're describing Spark, it sounds more iterative.
and it's more. I guess it's what it is. It sort of flows interim results down the chain of operations as they become available.
Okay.
That's called pipelining. And that's a very effective and I would say more performant operation. That's why you hear Spark being 100 times more performant than Hive, as Hive being the SQL layer on top of the traditional MapReduce interface.
Right.
So Spark is fantastic. We've been watching it for a long time.